Okay, let's continue. We got cut off. So I was saying, right, explain whether the bread will reach, I mean the temperature of the bread, explain whether it will reach a temperature of 26 degrees Celsius. Okay, so how do you do this kind of questions? You just like in quadratic functions, for example, you found the b square minus 4ac equals to, let's say, x squared or x plus 2 then square then minus 4, right? Then you have to start from this perfect square. I'm giving you an example. I'm not solving this question yet. I'm trying to relate you to the same concept you learned in quadratic functions. Okay, we just revised a few videos ago. You will say, oh, this, you will start with the perfect square, right? Because you know that the perfect square is always greater or equal to 0, right? Then after that, if this is minus 4, then you will minus 4 both sides. Okay? Oh, sorry, let's do it plus 4 lah, plus 4. Then you can conclude that, oh, this, which is your discriminant, b squared minus 4ac, is always greater or equal to 4, right? That means it's always greater than 0. So you say, oh, therefore, or you say, since discriminant is always greater than 0, so two real and distinct roots. Am I correct? So you remember, you start from perfect square. Now for this kind, right, you must start with the exponential equation. Because this topic is on exponential equation, is it? So you focus on that. Then slowly you branch off to all these numbers. But before you can do that, you must write it as a positive power. Okay? Positive power. So it will be e to the power of 0.1.761t. So to start explaining, you say as time tends to infinity. That means as time increases forever, or as time tends to infinity, as time tends to infinity, this number will become 1761. This number will be always what? This number will always it will become bigger and bigger, right? It will tend to means will approach, or you can say approach lah. Approaches, and then this one you can say approaches infinity, right? So you see, 128 divided by a very big number that is infinity, very close to infinity, must be getting nearer and nearer to, or you can say approaches 0, right? So your t, because this whole number approach 0, therefore the t will approach 26 degrees Celsius, okay, which is actually indicated by this graph that I drawn here. You see, you will get closer and closer to this asymptote t equals 26. Alright, so I hope you are clear. Okay, since we are on this topic, right, I've gone through with you how to sketch this kind already. Now let me just show you. Let's say the equation is like that. T equals 26 minus, okay, let's say this is 128 whatever lah. Okay, how different would the graph look? Firstly, what do? You settle the asymptote first, right? So you draw the asymptote. Remember, this is in terms of time, so don't draw the negative side. So this is your t equals to 26. Alright? Then this minus whatever here, how do you draw this part? How do you draw this part? So I don't know whether you remember or not, when you have a minus here, you flip this graph. Flip this graph. Is it like that? Okay, wait. I'm just trying to emphasize the graph. Okay. So it will actually be starting from here. See, you take 26 minus 128, that will be minus 98. Okay, then it will be like that, getting nearer and nearer and nearer and nearer and nearer. Okay, you check whether that is what you get, and then you can find this. How to find this? I told you already, when you are on T, you should have a T value. So the other one, the big T, right, will be 0. So you set the big T to 0, you will be able to get this value. Okay, maybe now we just solve, just to make sure you know what to do. Whatever. So K, actually you know, right? Then you 128. Then you must make this become 1, right? Then you ln both sides. Then you bring the power down. Okay, then you already know this K is 0.1671 something. Then you can divide and then find the answer already. Okay, yeah. So I hope you are clear about these kind of questions. So we revise surds, we revise bit of logarithms, we revise this kind of exponential equation which involves logarithms. Now we are going to do indices again. Okay, indices, just now I've shown you one kind, right, where you after that solve simultaneous equation. There's a little bit of manipulation there. This one is another kind of manipulation question. Okay, this is 3 times 2 to the power np over 2 to the power 3n minus 1 minus. I hope you still remember when I say that I say in class, right, that when you have something minus something, what must you do? You take out common factor here. Okay, and you always try to take out the smaller one. Alright, but if you can't, then you see how lah. Okay, never mind. I will show you what to do from here. Okay, so we are aiming for 2 to the power of np minus 3n. How do we get this? That means we must have 3n, and we must have np. np is here already. That means this fella stays. Okay? 2, okay, this means 2np divided by 3n, right? This divided by this is actually this, which means that it's actually this. So you can actually work backwards, and then you know what you want from here. This one already done, so we leave this fella alone. This fella, no, we need to take out common factor 2 to the power of 3n. Can you see that? So 3, I put a times as a dot. This one I don't touch it. This 3 I also don't touch it. This fella, I take out 2 to the power of n. If I take out 2 to the power of n, what is left behind? 2 to the power of minus 1 minus 2. That's what I get, right? Then okay, this one they tell you is minus 2. Okay, then now I can just use my calculator and press this one. I use my calculator and press. This fella, I leave it as it is. This fella, I leave it as it is. Why? Because these are the two things that I want. Okay, which makes up my this left hand side. Alright, so you stay here, you stay here, you stay here. I'll divide by 3. and I'll multiply by this here. 2 to the power of minus 1 actually is half. Half minus 2. And then you press calculator, right? You'll find that the answer is 1. Okay? So that's how you approach this kind of questions. Okay, of course you don't leave your answer like that. This is actually 2 to the power np minus 3n, and that's 1. So you have shown it already. Are we clear? So when you show questions, right, you can move backwards, and then that will help you to solve the question here. Okay? Now, after after that, they ask you to hence find the value of p. Oh, how to find? Hence means you must use this result. So I ask you, how do you solve this kind? You use, you know that anything to the power of 0 is 1, right? So if I want this base, I will just write this base here, then put a power 0, which means that my this power equals to this power. Okay, then I can take out n. So it'll be p minus 3 equals 0. Now, that means it's either n equals 0 or p minus 3 equals 0. Whenever you have something times something equals 0, right? Either this equals to 0 or this equals to 0. Okay? Yeah, so you have shown, oh sorry, you have not shown, you have found p equals to 3. Yeah. That's what they want, no? Okay? Now, we go on to another question. This question is a very common question, where they ask you find the range of values of p which satisfy the inequality. That means they're asking you to solve this inequality and then later find the range of values. The range of values of p means your p is not like that one. The p is not like 1, 2 or 3. No. This is called solve p. Solve for p or find the value of p. But they say range of values of p, then it's not like that. Okay? Range of values of p means there must be some inequality. And because this is greater than, right, then you'll be either this, and then some numbers in between. Are you clear? Okay, so let's see how we can do this. We cannot solve this when this is not 0. So first thing is to make the right hand side 0. Okay, now can you see that this is in the form ax squared plus bx plus c? This whole thing is your c. Okay, this whole thing is your b. This whole thing is your a. Okay, now you want class, you see this question you got to be very careful. You want this curve, this is a quadratic curve, right? You want this curve to be always greater than 0. That means it will never, let's say this is a x and y axis, it will never ever cut and then become negative. Okay, that means your curve can be like that, can be very near, but cannot touch the, cannot cut and then become negative. Cannot. Okay, that means your a must be, it must be a happy face, right? So this must be positive. Okay, we clear? Okay, now so this is the first condition that you must write. Now I'll recommend you write this on this side, then you write here 1. Or you can write 1 like that also can. But you just have to indicate that there's one condition and there is another condition. The other condition is that b squared minus 4ac, you see is never the curve, this is a curve, right? The curve, okay, sorry here. Because I've written it in the form ax squared plus bx plus c, right? the curve is always greater than 0. So is it ever going to cut? So there's no intersection, right? So no intersection means b squared minus 4ac less than 0. I hope you still remember. Okay, then you go and expand, then you get this, right? We use Jaron's method, always make it happy face. Then you solve, this will be minus 2, this will be 8. You want it positive, so it's either this or this. That is for solving this part here. Okay? But that's not the final answer because I told you there are 1, 2 conditions, what? So P must be greater than 0. Okay, you draw this, P must be greater than 0. This is 0, right? So shade or don't shade, you draw long. Then P minus 2, you shoot this way. P greater than 8. We want the P to satisfy both this condition and this condition, right? So this condition must be met, these two must be met, but the overlapping part is only this one. I never labeled this. So your answer is P greater than 0. Okay, this is a very common exam question, so you need to know this. Alright, now the other thing, last thing for this video only. There are other videos coming, okay? But I will stop at a certain time so that you all can sleep. Find the minimum. Okay, this one is an example. Okay, so completing the square sure come out one. Completing the square. Now there are a few kind of questions where you need to complete the square, and this is one of them. Later I'll show you problem sums which require you to complete the square. Alright. Now find the minimum or maximum value. Okay, this one just ignore. They ask you to express this in the form of this. When they say like that, right, they obviously want you to complete the square. Am I correct? Confirm have one, complete the square. If don't have, you come and look for me, okay? Sure have one, sure. Okay, then I told you, right, this doggy, just leave it one side. You take out the minus 2 so that your coefficient is 1 here. Okay, then you must check this times this is this. Yes. This times what will give me this? Must be plus 3x, right? Is it correct? Then you check this times this. Oh no, wrong. Minus times plus is minus, but they want plus what? So this must be minus. Okay, be very careful here. 2 times 3, 6. Yes. X, then x. Okay. So after that, don't forget to write this. Must not forget. Then this part here, right? Change it into a perfect square. Okay, so this will be x square. Then if it's minus, you put minus. If it's 3, you divide this 3 by 2. Do not write x here. Must use common sense. If you write x here, right, then these two will combine together already. Then there's no number, no constant already. So cannot write x here, okay? Then what do you do after this? You square this. You minus of square this, so there'll be 9 over 4. Okay? Confirm, you need to know how to do this, very important. Then now you expand. Expand this only. You don't go open up this bracket, otherwise 前功尽弃, you know what I mean? We work so hard to get this, then later you go and expand this, then what's the point of doing this in the first place, right? So minus 2, minus and minus is plus. If you don't know, press calculator, okay? You just press minus 2 times minus 9 over 4. You will get 9 over 2. The plus 1 is still here. Are we okay? Then after that, this number, you must combine them together. That will give you 11 over 2. Then now, that's how you get this part here. This part here, okay? Now, part A done already. Then it say hence. Hence means use this result. Fx is this. Hence, find the maximum or minimum value of fx. Now, the way to do this is like that. As I mentioned just now, start with the complete square. You must say like that. X minus 3 over 2 is all the square is always greater than 0. But it can also be equal to 0. Can. Okay? Now, if I times minus 2, you don't add first. You do the things that are nearest to your perfect square first, like times first, then later plus. So you times, if I times minus 2 both sides, don't you agree the sign will flip? Then you times minus 2 to 0 is 0. Minus 2 times 0 is not minus 2. Okay, then you plus 11 over 2. You plus 11, write the next line. Plus 11 over 2. Plus 11 over 2. Don't you agree that this is your maximum? Actually, you already know, right? This coefficient is negative, so it is a sad phase. That means it must be maximum. But you see, by doing this, completing the square method, right? You can see that, it's always less than or equal to 11 over 2. That's why the maximum fx is 11 over 2. Finish. Okay? Yeah, they ask you for maximum value, so you must state this particular value equal to this. Don't state this inequality. When do you leave your answer like this and not write this? Okay, I give you another question now. If they say hence, find the, if they didn't say this, if they say find the range of values of fx, or they say find the range of values that fx can be, okay, or they say find the range of values of fx, then your answer will be fx is less than or equal to 11 over 2. That will be your answer for this kind of questions. Okay, but for this particular question, they ask you find maximum or minimum value, you state that particular value only. That particular value. Okay, clear? Okay, I see whether we want to continue. I think that's all. I'll continue in the next video. Okay, that's all for this particular one.